insanely funny that our stream might starts with a, a sneeze. Yeah. So I've realized that the hay fever thing, hay fever thing is because of the wind. It wasn't because of the summer, the winter or anything. Whenever the wind's blowing really hard, I think it picks up dust, and then my hay fever just flares up really bad. Yeah, but yeah, enough with all of that. So, who am I? Hi everyone, my name is Zach Osiemo, and I'm a software developer who's open source software developer currently focused on building embedded systems and embedded systems in engineering. And I spend quite a bit of my time working on Zephyr particularly in Zephyr, I aim to work with the video subsystem and the USB subsystem. And I do this because quite a bit of my work is consulting for Tiny Vision, and where we built like a USB to MIPI bridge and so on and so forth. Yeah, so that's me. I try and do these streams as many times as I can. I'm attempting to do them every day, especially with December around the corner. It would be fun to manage to do them every day. So catch me whenever you can, and I'll be online. I'll try and announce my streams at least 10 hours before, so people can have like a plan of attending and such. And I might also try and like start planning them a week ahead, so it's easier to like catch up and go forward. If you want to know more information about the streams, there's in the description of the video there's going to be a link to our Discord community, which is where we hang out and we talk and we do stuff and we kind of decide what we're going to be working on and so on and so forth. And you can join the community. Let me know what you want me to work on. Let me know what you're interested in working on, and stuff of the sort, and we can work together. That would be entirely amazing. So, what are we going to work on today? If you clicked on today's thumbnail and you saw, I think you might be aware that we're going to try and learn how to do graphics rendering or displaying. I'm not so sure what the difference between rendering and displaying is, but we're gonna just try and learn graphics, and that way we can do testing on the video subsystem that we work on in Zephyr quite a bit, and sometimes the USB subsystem, which is a data transfer subsystem between devices and hosts. Yeah, so what I want to do today is to see if we can actually learn SDL, which is a simple direct media layer, which is a library. I think it's a library. It's a cross-platform library that works in macOS, Linux, iOS, Android, Windows, and several other platforms. And it's used a lot to provide low-level access to things like audio, keyboard, mouse, joystick, and graphics hardware. And it uses OpenGL, Direct3D, Metal, and Vulkan, and it's used quite a bit by video playback software. It's used by emulators and popular games, and quite a few games and such. So it's a good library. If you're interested in game development, this is going to be one for you. Although we're not going to be that advanced today. We're just getting focused on how to use the thing, I think. And if we're lucky, if it's simple enough that we can get it started and get it going, we're going to try to render an image. And if it's possible, we're going to try and render an image that we ourselves have generated. So the easiest way we're going to try and do this is work from the official examples, and then slowly start expanding those official examples out to towards the implementation that we want. I've personally not worked on graphics before. I haven't worked on graphics before, except like super simple graphics displays, like on LVGL and things of the sort, like embedded displays on graphics and such, and even then I used libraries such as, like right now I'm using SDL, so I haven't worked on like really basic graphics, but it's all, I know it's all trigonometry and probably a bit of calculus and such, and that's we'll see. We'll see how deeply we go into this. Hopefully we don't have to go that deep because we want to like traverse quite a bit of wide stuff, and my main interest is to do embedded stuff, and this is just a means to an end for me. So yeah, so let's try and get started with the SDL thing. I think the one of the easiest ways to get started with it is I found a tutorial here that is provided by SDL themselves. I think not this one yet. I think we're gonna start here. Yeah, so there's an easiest way to use SDL from by 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 SDL themselves. So the thing we're going to try and do today is to try and see if we can get this this particular implementation running and see if we can get it running locally and see what happens. Before I go on, does anyone have any questions currently so far with this with this stuff? As I start by make let's start by making some experiment where we can start working together on this. Does anyone have any questions so far? Documents, edge. Oh, okay. And this. What do we want to do? What do we want to do? What do I want to do here? Is I'm gonna make a directory and I go like hello SDL. Hello SDL. SDL3. So let's try this and then we can get from here and we can go see what we want to do really. So we have SDL3 and then the first thing we want to do is go back to here and let's now actually use this introduction by SDL themselves. So it's you can find out more about SDL from their website, which is I think SDL3 SDL. If I just Google SDL, we'll pick up SDL and we'll find them. So yeah, libsdl.org. There's a website there, and then it will display the current stable version and all of those things, and you can kind of read more stuff. We're gonna use more. We're going to depend on the wiki and the SDL GitHub today, quite a bit. But if you want to discover more about this, this is what you're going to be using. libsdl.org. And I like using the dark theme. Yeah, clearly this is used for games and such, and it's going to be quite insanely interesting to do. So let's see if we can do a simple version of this, and maybe we can run something simple, and then we can start kind of building up towards more complex use cases. The actual use case we want is to do something like SDL image, I think. So SDL image. This is a simple library to load images of various formats as SDL surfaces. I still don't know what an SDL surface is. It can load BMP, GIF, JPEG, LBM, PCX, PNG, PNM, all of those variations, QOI, quite okay image, and simple SVG format images. It can also load all of the other ones there. And this library is distributed as a zlib platform, and it allows you to do whatever you want to do. There might be already an example which uses SDL image. Amazing, this is cool. So we might even actually be able to do this. Wait, SDL image hello C. Cool. So as hello C already has I guess there's a few versions of hello C. So let's actually run this super simple version of hello C, and then we'll see what we need to do. So that they say here you can do this quite a few ways. So there's a few ways of doing installation of SDL. If I'm going to be honest, as described here. So you can do installation. You can do installation by using like your package manager, and I think I had an example somewhere here. Somewhere here in the wiki. The wiki has a So in the wiki, there's a good installation, libSDL SDL3 readme. Let's go open that. wiki.libsdl.org has a good explanation, and I think the libsdl3 readme, isn't it this one? No. New features, no. How do I get to that page? Installation, probably. No. This is not exactly what I want. I don't know how I found this page, but the wiki libsdl3 readme Linux, readme Linux, readme Linux. Do I need to go git repo and go like readme Linux or something like that? SDL3 Linux, SDL3. Okay. And then if I go into libsdl3, is there a readme Linux in here? Control F, readme Linux. Yeah, there is one here. So cool. So there is one here, and if you open this, it'll basically bring you to this one, and this is how you install it. And by the way, I think there should be enough Windows, Mac OS, whatever platform you're using, it should enable you to install this from there. So cool. But let's start with the easiest simple way of using this, and the easiest way of using SDL is to include it as a sub project in your project. Let's start by creating a simple project and to build and run Hello C. Cool. So we have this one here, and I think Hello C is let's open this in a new tab. What is this? Hello C. I will copy this verbatim, copy raw file, and then I'll come here and I'll do nvim and then in here I will do hello.c and then Control Shift V, Control SQ. If I do something like paste, should be Control Z. Hello C. Copied raw file. Paste. Yeah. Okay, there you go. We can do that. So we have there we go. We have a Hello C in there, and then now let's actually do some project that builds Hello C, and we can go from there. Let's clone this. It might take a while, so if you have any questions, we can start that now. We're going to clone it into a sub module in the project, and then we'll go from there. I see a few more people have joined. Does anyone have any questions? Does anyone want to ask anything while we're cloning this SDL library right now? Any questions so far on what we're doing and how it's working while that is copying? Any question? Okay, amazing. So we have libSDL installed. There you go. We have libSDL installed, as they say. So what we need to do here is just make CMake lists. We need to make a CMake list, and this CMake list is going to contain this, and then this is going to enable us to make a make file and build this thing and see if we can run it. That should be quite simple. So let's actually go here, and I think the easiest way is to do CMake I remember this is, the spelling of this can be weird. cmake.txt. Isn't it the same thing? Isn't it cmakelist.txt? And then I'll copy this and I'll put this in here, paste it, and then the only change I'm going to do is remove this win32 executed. What they do here is require a minimum version of 3.16, and then they label this project hello, and then this sets the output directory for build directories, for build objects, to make sure the dynamic libraries go into the build directory automatically. So that's what these two do, and then it adds the subdirectory vendor SDL exclude from all. It just makes sure that it's available. I think we can actually check cmake add subdirectory. Add subdirectory options. Add subdirectory. What does exclude from all? If the exclude from all argument is provided, then the exclude from all property, set this directory property to a true on a subdirectory to exclude its targets from the all targets of ancestors if excluded. Okay, so you don't want this directory build if all targets are chosen. So if you use like a normal make command, you want this directory not to be built because it's a library, it's linked. Okay, cool. And then you add the executable hello C, and then you link to the actual SDL3 library, so that's, you link it to that, and then that should actually work. Luckily we're a bit familiar with this from Zephyr. So cool. And then what's the next thing we need to do? Once we've made that, we want to do a cmake-s dot cmake-s this directory, and then make a build folder build. So cool. I'm hugely glad that this is working so easily, because it never really works like this. And I'm actually quite glad that we did not try to do the platform installation, because if we did the platform installation, this would have been, oh my word. CMake error at vendor SDL. Couldn't find dependency for Xtest. Please install the needed packages or configure with that. Okay. Yeah, I think Xtest. I will go with that. Gone. -d SDL X11 Xtest. So I think this is going to be for that's just going to be needed for running tests, and build files have been written, and that, and then all of this is already, yeah, I don't think anything is wrong, so that is fine. It's been generated, it's been built. Let's see if that works now. So now let's do cmake. We can actually find out what these do. So if you want cmake-s, what does that do? Yeah, I like doing this. I like going through all of this as I'm doing it, because then it's easier to, I'm not just using stuff, and surely there's sometimes someone who doesn't understand what is happening, and it just makes more sense to actually go through what I want to know what that command is. cmake-s. I would like to read what that command is. Reference document. Does anyone know what cmake-s does? So cmake- I can actually do cmake help, and that would tell us what it does. So cmake-s source. Okay. Path to source. Okay. So cmake-s. Let's see. So cmake-s, this is the path to the source. This is a source directory, and then -b, path to the build. This makes build a build directory locally. and then that's actually what just happened. So you can see there's a new build directory, and the source directory is this one, and that's basically what that does. And now that cmake-s, what that does is it builds our own, it makes a make file for us, basically. ls build. There should be a make file in there, so there's a make file somewhere in here. This make file, cut build make files. So that's what it does. It makes a make file, and this make file is what we're going to run now. And then when we run this, it's going to actually build what we want to build and run it. Cool. And let's run the next command. So cmake build --build. If we want to run that, we want to find that out. Let's find out what that does before we go build. That's easy. Then we know what happened. --build. So what does that do? Project binary directory to be built. This is required unless a preset is defined. So yeah, just does a build for us. So what do we run? cmake --build. Okay. cmake --build. Cool. So this is now building. This is now building the hello thing. Does anyone have any questions so far? Hopefully this actually works. I'm super scared. If it doesn't work, then oh my god, I already saw an error. If it doesn't work, we're in trouble. I already saw some sort of error. But if it doesn't work, we have to go debug it, and I don't want to debug SDL because I don't know what the SDL does. I don't know this library at all. Should have failed though. LOC 69.9. Is that the only error? Perfect. Let's go look at that. Yep, that's the only error. So let's go look at hello C and see if we actually added some code by mistake. Yep, there's no code after that. So we did indeed add some code by mistake, and then let's do actually code. So I don't know if I want to do both of them again. No, let's just around safety and do it again. Oh, it actually built. So it actually built. What do we expect? What does it want us to do after this? We need to cd build run hello. Okay, or run it from where we are. We can also do dash build hello. There you go. There you go. We have SDL running locally. Amazing. So we actually have this running now. So the best thing to do right now is to start actually exploring the code, because if we can just get to understand how many lines of code are in here actually. It's like 60, 67. If we can get to understand this 67 lines of code, then we are actually half of the way there. Yeah, we are half of the way there. We basically understand. We've figured out how to install SDL right now. We figured out how to build a program that uses SDL, and we have actually figured out how to make a make file and run the program that uses SDL. So right now the next task is going to be to actually understand what these functions do, so that way we can kind of start actually being able to use them. And I expect that this is graphics intro. Gouge is graphics. So I think if we can do that, and we can do this is 1800, and then this one is 1600, and then a full screen and a render, and we'll see if that actually changes anything. We'll yeah. So this is draw color is that's gray, draw color, that is gray. So opacity, all of that. If I do this, draw the message, set renderer text. Let's do this RGB. Let's make it blue. See if we can make it blue. See if we can guess our way to making this thing blue. Okay. Why is it opposite? So let's actually see, or maybe that is RGBA. So this is 0, and then this is 255. So this should actually give us blue now. So I'm thinking of this is probably RGBA, and let's actually see if this actually changes anything. We actually know what we're doing. Cool. Fine, cool. So now actually let's go and understand this code. Yeah, we're well on the way there because we have SDL running. We can build an app with SDL and we can run it. So copyright Sam Lantigua. This software is provided as is without any express warranty and stuff. Actually, because we've started changing this, we can alter it. So let's remove this so that we make the source less. This is my trick. I always want to make the source as little as possible so that we can actually understand what is happening. The other thing I'm wondering is, do we wanna SDL app init, SDL app event, SDL app iterate? This function runs once per frame and it's the heart of the program. Okay, cool. So I see. So we're running an app we're basically rendering frames at a certain interval. We're always rendering a frame. That's basically what we're going to be doing. So let's actually, I see now. Where do we start? Oh, did it actually do the thing we wanted it to do? Yeah, that wasn't actually, it didn't do what I wanted it to do because it actually didn't write what we wanted it to write. It did not type. Oh, Gauchos. So this is probably the label of the window. Let's see. This is probably the label of the window. I wonder if we can do SDL window something else. And then there should be some text somewhere, messages somewhere. There should be a message definition somewhere. Aha. So this is SDL graphics. SDL graphics from Gauchos. Okay. Build it, run it. Let's see what it. SDL graphics from Gauchos. So that's fine. Okay, so let's actually start using the documentation and try and find out what these functions do and kind of like go through it and stuff of the sort and go through it. So we can probably just go into the documentation and start finding out what the window, what the renderer is, and all of this, what SDL app init does, and then we can just go through all the way to the bottom, and hopefully we can get to a point where we do not render it as a full script window so that we can see if our title actually takes effect. Before I keep going, does anyone have any questions about what we're doing and what is happening so far right now? Does anyone have any questions? Does anyone have any questions? Does anyone have any questions so that I can answer any questions before I rush forward with everything? I know Yassine says it takes 30 seconds for you guys to hear what I say, so I'm going to wait a bit. No questions so far? That means I'm either making it super obvious, which would be amazing, or I'm actually making it quite difficult, which is not what I want. No, that's the wrong window. And yeah, I want to do a control minus. It's fine. I think this is because I set the text quite huge in my settings, but it's cool because then you guys can see what I'm doing, or everyone who's watching can see what I'm doing. Let me not say guys, it's a bit derogatory to say that. Let's go into SDL. Let's try and learn what these functions do, and then see if we can actually change this into a thing where we decide if we're going to go for the image today or if we're not going to go for the image today. Yeah. So let's actually go into the graphics. Let's go into the documentation. So I want to find out what an SDL window is and an SDL renderer is, and then we can kind of go from there. So I want to find documentation. API by category, API by quick reference, API by category. No, I don't like that. API by quick reference. I'm not so sure I like that. Complete API index. Yeah. Yeah, I think so. I think this is quite difficult. So we want to look at window. Is there a window or something? It's a shame that there's no way of me doing a search, because that would have been amazing. SDL, please. Let's add a Doxygen search on the side. It's here. So let's start there. There is a search option. SDL window. So SDL window. What is an SDL window? SDL3 SDL window. So this is this struct is available. It's a SDL window is defined in video H, and yeah, it looks like it's just a window. This struct uses as an opaque handle to a window. So whenever we do the thing, whenever we run it like this whole thing, the handle for this whole thing is that's actually amazing. That's coincidental that it is actually blue. It's very coincidental that it's actually blue because we are blue. The which is blue. But let's keep it like that. So this is a handle to a window, and it's set as null. So we start with the static window set as null, and then let's go look at the renderer. So let's look at that. Let's submit that. There's this, and this is a structure representing a rendering state. So probably when we do updates, when we're working in our thing here, we're going to be working on the renderer quite a bit. What did we call it? A renderer. It's a pointer to a renderer. I think we'll be there you go. We'll be get renderer output size. We're going to be affecting it a lot whenever we're doing the iteration of each frame. So that's a renderer. Defines a window. Define window handle, and then let's actually add this here. define handle node to rendering state. Okay, cool. So now I shouldn't have done that. I should not have done that, but it's not a problem. Yes, I should not have done that. So the next thing we want to do is we actually want to look at this function runs once at startup, SDL app init. What does that do? It probably sets up some defaults for us, and we want to find out what it does. So let's go back to the search and then look at app init. App init. Okay. App implemented initial entry point for SDL main use callbacks app. So main use callbacks app. Do we have main use callbacks app? There's something we defined. Main use callbacks app. So use the callbacks instead of my main. So there's a macro here, or there's a config option here that is it's a define. If it's defined, the whole application will do something different. So let's go find out actually what that does. So main use callbacks app. Inform SDL to use the main callbacks instead of main. Okay, so if we define this, SDL does not define this macro, but will check if it is defined when including SDL main.h. If defined, SDL will expect the app to provide several functions: SDL app init, SDL app event, SDL app iterate, and SDL app quit. The app should not provide a main function in this case, and doing so will likely cause the build to fail. Okay, cool. So yeah, so this is, yeah, I would like to do that. This would actually just work because it's in there. White space doesn't matter. So rather, okay, cool. So this macro over here that we have just defined, that is defined, well, we can say we have just defined because SDL does not define this macro. So what this does is that it forces us to include an app init, an app event, an app iterate, and an app quit over here. And these, we can do stuff in all of those functions that we'll see what is expected and such, and so on and so forth. So cool. So how did we get there? Defines a rendering state, defines, so this is app init. And why did we look at the main use callbacks app init? Oh yes, so we looked at the main use callbacks because app implemented initial entry point for SDL main use callbacks. What this is saying is that this is the initial entry point for the application. Basically, this is your initialization of the application. This is where you build the application up, and this is how you're going to use it. And if we read further, apps implement this function when using SDL main callbacks. If using a standard main, you should not supply this function. This function is called by SDL once at startup. The function should initialize whatever is necessary, possibly create windows and open audio interfaces, etc, etc, etc. So if you're making a game, or you're playing some video and you want to do, like, remember what we were doing yesterday? We were taking audio interfaces, we were taking USB interfaces, we were like and implementing other things and so on and so forth. So let's say for example the USB application that we built yesterday, where we were actually taking interfaces away from the kernel itself and trying to make sure that we can use them within that. We would do such kind of setup in this app init function, where we would be like, okay, so I'm going to use this thing and I'm going to use it as some sort of data ingestion thing. So I'm going to take it away from the kernel and I'm going to set it up so that every time I run a frame or I grab a frame, I'm going to be able to use these interfaces and such. And that's what is described here. So this is going to be basically setting up all the resources that we need and such. And in here, ours is quite simple right now. As we can see, we start by SDL create window and renderer. Let's see what that function does. SDL create window and renderer. Create window and renderer. I would expect we yeah, let's touch that. Window and let's search that. Create window and renderer, SDL3. Create a window and a default renderer. So I would expect that in here, yes, we are passing in this window and we are passing in this renderer, this window and this renderer, and these are the ones that we've defined up here, SDL window and SDL renderer as always. And then what the first thing, the parameters that this takes is number one, the function parameters is the title of the window, which is the guy who chose graphics. And then it takes the width and the height of the window, which is 1900 by 600. We can also do something like, let's do 900 by 600, but I don't want to set it as full screen. So, and then we can take as window flags. So window flags, I do not want it to be full screen. This is the first thing I want to change. So full screen, I don't want it to be full screen. I don't want it to be hidden. I don't want it to be borderless. I don't want it to be minimized. I don't want it to be maximized. I just want it to be some sort of, let's do a window model and see. Let's do a window model and see. Let's do a window model so that we can actually see what happens there. And then if we run it, okay, cool. So that's perhaps we just go with a maximized window so that it's maximized, because I don't want to do a model maximize. I don't want it to be full screen because I would like to see the title of the window. So cool, amazing. There you go. So Gaiocho's graphics, SDL graphics from Gaiocho's. There you go. And I think we can do something like a window resizable or something. Yeah, that's the one I thought. Oh yeah. I'm getting this quite quickly. SDL is quite an intuitive library. I mean, I have no familiarity at all whatsoever with this thing, and I'm just going at it. So I would say, and I'm not, I've never worked on graphics before, and I knew this was resizable. This is we can make it small, we can resize it, we can build it like that, we can do everything we want. There you go. Yeah, cool. So that's amazing. That is amazing. And if we do escape, it goes through and it stops. So cool. We know what flags we're taking. We know it takes what flags to supply, and then we have we can supply the window itself and the renderer itself, which is a pointer to a pointer. So these are going to be pointers as well. So it's going to mean, yeah, this is a reference and a reference. So it's a reference to something that's already a pointer, and cool. If this does not exist, if this does not succeed, we will if this does not succeed, and I don't know what it returns a boolean. So if this returns a false, it will fail, like we did with the modal here. As you can see, modal, because this does not supply a parent window, this is going to fail. CMake build, and if we run it, couldn't create window and renderer. There you go. Window must, so it just says, it just basically gives us this error, couldn't create window and renderer as SDL get error. There you go. That is the thing, resizable. This is actually quite simple. I think this is amazing. Yeah, so SDL app continue, and then it returns a boolean, and I think this is wait. This app result, SDL app result. So we want to see what an SDL app result is. SDL app result. App result. Okay, cool. SDL3 as returns values for optional main callbacks. So if we return an app continue, this is that requests the app continue from the main callbacks. Success requests termination with success from the main callbacks. Failure requests termination with error from the main callbacks. So SDL app failure, there you go. App success, so app continue, and I think so I think we can do some sort of log here, some sort of quit here. This function runs once at startup, and I want to do what is it? SDL log. And then I don't want to get an error, but I just want to run a log sp. That's, yeah, cool. Thank you. And I just don't want to do all of this, and I want to do that, and then I want to remove this, and then I'll say app quit SDL log app quit successful. Yeah, and then we can do a new line if we want. And I think the other thing we can do is return. I want to return, the reason I wanted this is I wanted to return SDL app termination from the main callback successfully. So SDL app return. Wait, this doesn't have to be a void, isn't it? SDL app quit. Okay, cool. I see. So this is just gonna log. It's not gonna do it. This is a app quit. It doesn't. We're actually looking at it right now. So app quit function pointer for that. And what this is used by as enter a main app callbacks. This mechanism operates behind the scenes for apps using the optional main callbacks. Apps that want to use should just implement app event directly. So basically this is just app, no, actually not app quit func. I want to look at app quit. So yeah, app implemented the init entry point for SDL main callbacks. Apps implement this function when using SDL main callbacks. If using a standard main, you should not provide it. This function is called once before terminating. This function will be called in all cases, even if app init requests termination at startup. This function should not go to an infinite main loop, and you do not need to call SDL quit in this function, as SDL will call it after this function returns before the process terminates, but it is safe to do so. The app state parameter is an optional parameter, and yeah, so this is just an deinitializer. Let's look at that. We've sort of jumped to the bottom, but I wanted to make a log in here so that I could see if something actually happens. Let's build it, and then we can just run it and see. And then obviously we press escape, app quit successfully, and cool, there you go. That's working. That removes itself. Yeah, before we keep on jumping, does anyone have any questions? And we know why this is returning app continue. This means keep on going with the stuff, so we know what that works. Create the window. So where did we want to do? Creates the window, creates and sets its initialization stuff in this section. Okay. Excuse me. Cool. So that actually works. So now let's look at this app result SDL app iterate. Cool. Anyone have any questions so far? So yeah, let's look at SDL app iterate. App iterate. Let's see how ready. So app implemented iteration entry point for SDL main use callbacks. Remarks. Apps implement this function when using SDL main callbacks. Cool. This function is called repeatedly by SDL after SDL app init. It returns app SDL app continue. The function should operate as a single iteration in the program's primary loop. It should update whatever state it needs and draw a new frame of video usually. On some platforms, this function will be called at the refresh rate of the display, which might change during the lifetime of your app. There are no promises made about the frequency this function might run at. You should use SDL's timer functions if you need to see how much time has passed since the last iteration. There is no need to process the SDL event queue during this function. SDL will send events as they arrive in SDL app events. And in most cases, the event queue will be empty when this function runs anyhow. This function should not go into an infinite main loop. It should do one iteration of whatever the program does and return. The app state parameter is an optional pointer provided by the app during SDL app init. If the app never provided a pointer, this will be null, and if the function returns SDL app continue, the app will continue normal operation, receiving repeated calls to SDL app iterate and SDL app event for the life of the program. If this app returns SDL app failure, SDL will call SDL app quit and terminate the process with an exit code that reports an error to the platform. If it returns app success, SDL will call app quit and terminates with an exit code that reports success to the platform. This function is called by SDL on the main thread. So remember what we started with. When we started, we said the reason I'm doing this is I'm making a video display application because I want to be able to display video from devices via USB, via UART, via serial and such. And in order to display video from devices, we have to decide what frame rate we're doing, how quickly we're receiving frames from the device, and then how quickly we're rendering how quickly we're actually rendering the frames on this application and such. And so it appears as though this is the function that we call, and what they explain here is that this function will be called at the frame rate that is set for this app. On some platforms, this function will be called at the refresh rate of the display, which might change during the life of your app. So it might depend on the display that you're using. Like right now, I think my monitor is using, if I do that and I do displays, if I do displays, I think my monitor, which one is this one? This is the Samsung. It's going at 60 hertz. So I'm expecting that this is being called 60 times a second. Okay. There are no promises made about the frequency this function might run. You should use SDL timer functions if you need to see how much time has passed since the last frame rate. So if you want to run a different frame rate, you basically want to if you want to run a different frame rate, which means render at a rate that is defined by you, then you need to do something of the sort of like, I would say you need to do something like how would you do that? If I want to run a different frame rate, So this is 60 FPS right now. Maybe I want to run like 900 FPS. What do I do? What do I do? So I would set, SDL has timer functions. So, and these timer functions might enable me to trigger up iterate to run faster. I think at some point something is going to be able to give me an option of setting up iterate to run faster. I think so, but we don't know what that thing is yet, and at the moment right now that is not the most important thing to know. What we need to do is first of all just go through the whole thing and understand what it is in the first place. Once we understand this whole thing, then we can go and think about how to do up iterate and things of the sort. Okay, cool. So this is fine. This is fine. So okay, so cool. So we know this is called right now. This is called at the rate of whatever at the rate of the screen. So this is called 60 times a second. Okay, so in here we just define what we're going to fill our window with, which is actually quite insane. It's funny because we jumped right into app iterate without doing app event, but we'll look at app event just now. So in app iterate, what we're looking at is we make a message which says SDL graphics from Gaiochos, and then we make a width and a height of 0, and then we make a float and an X and Y, and then we make a constant scale of 4.0. This is how we're going to scale our floats, and then we get render output size, and this is called center the message and scale it up by width and height. So get render output size, get render output size. What does that do? Get render output size, get render output size. Yeah, so what does that do? The current output size given in pixels of a rendering context. So, and I think we set that up here, 900 by 600, and this is the thing that we send. Create window and render up 900 by 600, and we set it to that. So we get it to that, and then we set the render scale. So we set the render scale. Set render scale. I think we like make it in some sort of weird way. So what does this do? It takes a renderer, a float X and a float Y, and okay, cool. And then what do we do here? The drawing coordinates are scaled by the XY scaling factors before they are used by the renderer. This allows resolution independent drawing with a single coordinate system. If this results in scaling or sub-pixel drawing by the rendering background, it will be handled using the appropriate quality hints. For best results, use integer scaling factors. Each render target has its own scale. Each render target has its own scale. This function sets a scale for the current render target. Okay, cool. So it basically scales how much we're going to be doing this. So here, let's see X and Y. It sets a scale to 4.0. This is a float. This is not an integer. But if we just used an integer, it might even be better for something of so. We can actually do something like 8. Let's see what happens if we do that, so that we can actually build some intuition around this. Build hello, there you go, and then we can, so it just that just scales it way out. And if we do something like 2, I don't think we'll be able to see it. I have a feeling this is somehow logarithmic or something of the sort. Yeah, okay, cool. Okay, cool. We can actually go 0.5 maybe 0.5. Let's see 0.5. What is 0.5? 0.5. 0.5. What does that do? Let's make build hello. Yeah, there you go. It's quite small. Okay, cool. So I'll go back to I'll actually do. Let's actually make a funny one and go back to 5.5, which is the one we haven't used before. And if we actually build and we run this, we should get some. That's a bit much. So 3.5. let's go a bit backwards, retard it a little bit so that we can actually do something else. So let's make cool. There you go. 3.5. It's a little different, you know. We're changing everything so that we get an intuition of actually how it changes. So the smaller the scale, it's scaled. If you go like less than 1, it's scaled 1. If you just scale it to 1, it will be what it is, you know. And then there you go. So the X is width over scale minus SDL debug test font character size times SDL string length message times 2. So it does some we basically center the message and scale it up. I see. So we look at the width and the height, and then we go and, you know, we set these things according to because here I think this, let's look at this SDL log. SDL log, I want to see SDL log. I think if we do this, I want to see here SDL log. Let's do a H width, and then I want to do a D, and I want to do a D, and I like doing these, I like doing that, I like doing these, and I like doing that, and then I want to go here, and then I want to go do this, and I want to make a new line, and then I want to do that, and I want to close this, and I want to say width and height. Okay, and then I want to come back here, and I want to see what they've been set to, because I have a feeling they get set to what I have a feeling that they get set to come on. Before get output size after get out after get output size, and then this is going to be W, this is going to be H, because that's how the variables are arranged. This is W and this is going to be H. So let's look at it. So let's build that. Okay, cool. Fine, thank you. Okay, cool. So this is going to be logging quite a bit. Before it's going to be 0 as expected. Before it's going to be 0, and after it's going to be 900, 600. This is doing it every it's doing it every second. So basically every 60 times a second. As it's quite a lot. So cool. So there you go. We know what that does. So it's get output size, it sets them to something, and then it sets a render scale and render a scale, and then we determine X and Y from both the scale and the width and height that have been set from the render that we set in the output init. And then we set a rendered row column, and I think here we made an opacity, so we can make this 255. Actually, white RGB FF. So really, 255, 255, 255. I don't believe you. So 255, 255. That feels like it's just gonna be gray. Logically it makes sense, but it feels like that is just going to be gray. Okay, cool. So yeah, there's white. This is kind of more of our color right now because our streams usually have a white background on such amount of things. Yeah. So there you go. Do we wanna? Where do we set the font? Do we set a font ever? SDL debug text font character size. This is just a size. We don't really set the font anywhere, but this is just a debug font. So there's probably some more we can do. So set renderer draw color. This is the background, and then we clear the renderer with that. Okay, cool. Set renderer draw color, render that, and then we set renderer draw XY message that. I see. So what we basically do is we can we clear the whole renderer with that, and then we set render debug test or okay, we can do this. Set renderer draw color. We can look at this. I'm now just sort of intuitively defining what these things do instead of looking at the documentation. That's how you know that's how you know a library is good. Set render draw color. Set render draw color. Set render draw color. Yeah, so set render draw color. What does this do? Remarks. Set the color for drawing or filling rectangles, lines, and points for SDL renderer clear. Okay, cool. So that and render clear. What does that do? This function clears the entire rendering target, ignoring the viewport and the clipped rectangle. Note that this clearing will also fill all pixels of the rendering target to whatever color. So cool. So this actually just sets the color for the whole thing, as you can see here. As you can see, if we have that thing running somewhere, it sets the whole white basically. Sets the whole white. Yeah, cool. So that's fine. And then render draw color, set render draw color. We know it's setting the render draw color for that. It's setting it to blue basically, and an opacity of it's fully opaque, but it's blue. Set render debug text. Set render debug text. Set SDL set render debug text. It takes a renderer, it takes an X and a Y and a message. But it also we've already set a color, so it will use the color that we have up here. So debug test. Set render draw text. Isn't it? Set render debug tests. Set render debug. Set render debug text. Oh, okay, cool. So I see. Render debug text. Yeah, here. So this function will render a string of text to an SDL renderer. Note that this is a convenience function for debugging with severe limitations and not to be intended to be used in production apps or games. It accepts UTF-8 strings. It only has a single tiny 8x8 pixels, so you can use logical representation. It uses simple hard-coded bitmap font. It does no word wrapping and does not treat new line characters as line break. If the text goes out of the window, it's gone. That's it. Basically, that's what it says. For serious text rendering, there are several good options such as SDL3, TrueType, and other external libraries. Cool. So we're not going to do that now. We're going to just look at this and set render present. Let's look at render present. SDL render present. Yeah, SDL render present. So what does this do? Remarks. As we've seen, this takes an X and a Y and a message, and it's set. So it takes the renderer the X and the Y, and then it sets the origin X and the origin Y, and then it just writes a message onto that. So SDL render present, I think this SDL's rendering functions operate on a back buffer. That is, calling a rendering function such as render line does not directly put a line on the screen, but rather updates the back buffer. So there's a front buffer and a back buffer. This is it's basically a double buffering thing. So in double buffering, what you're doing is you are displaying the front buffer while operating the back buffer. So you're manipulating the back buffer. You have this buffer where you're drawing on, and then you present that buffer, and then you get the buffer that was presenting, and you draw on that again. So what this does is it enables you to do more stuff in the background, and you're working in the background while something is being presented, and you can always be working on the next scene on the buffer, and then once you're done, you're doing that. Therefore, when using SDL rendering API, one does all drawing intended for the frame and then calls this function once per frame to present the final drawing to the user. The back buffer should be considered invalidated after each present. Do not assume that the previous content will exist between frames. You're strongly encouraged to call SDN render clear to initialize the back buffer before starting each new frame's drawings, even if you plan to overwrite every pixel. Please note that in case of rendering to a texture, there is no need to call SDL render present after drawing needed objects to a texture, and should not be done. You are only required to change back to the rendering target to default SDL render target render null afterwards, as textures by themselves do not have the concept of back buffers. We will find out about this way later. I think for today's purposes of doing an introduction to SDL, not a problem here. Cool. Cool. So there it is. We have the SDL app iterate, which is the meat of the application, done. So let's look at app events. This function runs when a new event, mouse input, key presses, etc. occurs. So this is where if you're making a game and you have navigation, you have a mouse, you have this key, you have that key, you have all of that thing. This is where you would handle those keys. So you would handle like key combinations and things of the sort here. What we do have here is that any key, if we run this, any key, so I'm just pressing any key any event, as you see, I'll do this, and I'll do a mouse, I'll click and I'll click somewhere, there, it's gone. So what we have here, basically, oh, cool, sorry, that is actually not true. Basically what we have here is, and what if I close it? App quit successfully. So what does we see? So any key down, rather, I thought it would be, so this function runs when a new event, mouse input, key presses, etc. occurs, joystick, whatever. Event type, if event type is SDL event key down, or if event down is SDL event quit, so the close that I had up there, return SDL app success and the program reporting success to the opportunity. So app event just handles any events that happen in the application. I've been droning on for, let me see, I've been droning on for 1.5 hours right now, and I feel quite comfortable that I understand the kind of basics of how SDL works. Does anyone have any question? We could do this for another hour, where I would try and do like use the image thing and present images, but I think I like doing them in chunk size bits like this, so that there's always more stuff to cover as we go along. Does anyone have any questions for what we've just done? Does anyone have any questions? I feel like this was a really awesome, for me, git status, git init. Okay, git status. using git submodules. I haven't used git submodules, so I don't know how to. Well, I've used them, but not directly. So practical example 21. Assuming. I want to know how to not commit the submodule up and just point to I'm trying to label the other thing as a submodule so that I can I'm confused. That's actually convert directory to submodule. I'm trying to find out how to do this as a submodule so that I can just push this up and okay, cool. So I see what I need to do. I just need to remove vendor SDL. Vendor SDL. I think if I'm correct, I just need to remove vendor SDL and it should work out. Yeah, here you go. So I just need to do instead of this. Yeah. So rm-rf vendor SDL. Okay. ls git status git so and then I want to go back here and make a let's save this and then let's go here and let's make a new folder. Let's make a new file .git ignore, and then in here we wanna do all ignore all build directories. Cool. SPV, and then if I go here and I go git status, build should have disappeared and I should have added those two. So git add .git ignore cmake lists hello c git status git commit -m git commit -m. This is going to be initial hello.c example for SDL3. That's fine. This is really simple. And then let's go in and add readme SDL3 explorations initial explorations example uses SDL3 as a submodule, as a Git submodule. Comments and changes the basic hello.c from SDL3 so one can see what the code does. Okay, cool. And then that's cool. Come on, I'll leave it at that, and then I'm gonna if I do this, what do I do? It's quite rendered. Nice. Okay, cool. Git status add readme git commit -m add readme to the project. Okay, cool. And then now I want to add the submodule. Isn't it? Repo URL. That's fine. Git add submodule. Git submodule add repo URL folder. Okay, cool. So what I want to do is instead of doing this, yeah, git clone. I want to do Shift V. Instead of doing that, I want to do submodule add, isn't it? Submodule add. So and this would also mean that we can just basically run it I'm just waiting for it to clone up and then we can finish up. Any questions so far? Any questions given about today's stream? I think at some point in the next coming week we'll work on rendering a PPM image. I could do it now, but I don't want to cover too much. I think that was a really exciting introduction, and it kind of sort of worked for us, and I think I'm quite happy with that. So cool. So let's see if that actually works out. Cool. And I think if I wanted to go back and actually just build it, just to make sure that this is build. All you did is just ignore the function, so this should be okay. I just want to make sure that it's working as a submodule now, and I can commit it up so someone else can go get this code and just run it, and they should be able to use it. Okay, and if I do hello, cool. Let's probably add some instructions here in the README. To build and run the project, last initial build we did that I'm looking for? Yeah, this. Copy. And I think I'm gonna go with this guide. There's a guide. There's a guide. So what we want to do is yep. So to build and run the project, one, clone the repo. Two, run tested on Ubuntu, and then three, build the app, with I think that, and then we can run that. Four, run the app with build hello. You should see a window with some Gaia Ocho's text. Okay, git status. Oh, git add, git commit -m, add SDL as a sub module. Git status, git add readme, git commit -m, add building and running instructions to readme. Okay, perfect. And if I do, I want to just go to GitHub and I want to go to Gaucho's, easily Gaucho, and let's just view organization, and we can do repositories. We can make one new repository. Let's make a SDL3 intro to SDL3. Okay, cool. So let's create that. Should be nothing here that actually you want to do that. Git branch -m, git -m main, and then we're gonna git remote add an origin there. Git push -u origin main. Boom! There we go. So Gaucho SDL3. There we go. Vended. This should be a little, yeah, it should point us to SDL. Amazing. If you go there, it just points to SDL. Thank you so much. That has been an amazing 1.5 hours. We've basically explored libSDL. We've found out how it works. We've kind of played around with it, and I think it works really well. And I'm fairly confident that we can actually build more stuff based on it. I think the next time we try SDL, we're going to actually try and use render an image during a window, and we'll see where that goes. Thank you all so much for coming today. That's been amazing. Remember, my name is Zach, and if you want to support me, you can support me using the GitHub sponsors thing, and feel free to subscribe, like the video. That really helps. It encourages me to do this, and I will try and schedule all the rest of the coming screens soon. Thank you so much. Cheers, and see you next time. Remember to be daring.